Hey everyone, welcome back to the channel. Today we're going to build a simple linear regression model from scratch. We'll go through a step-by-step guide using real-world data to understand how this fundamental algorithm works. By the end of this video, you'll have a solid grasp of the linear regression process and be able to implement it on your own. Let's dive in. First, let's quickly review what linear regression is. Linear regression is a method used to model the relationship between a dependent variable, let's call it, and one independent variable, the mot. The goal is to fit a straight line through the data points that best predicts based on. The equation of a straight line is y plus beta 00 plus dash beta over x, where plus beta 0 is the intercept, the value of when is 0, while beta 1 is the slope, the change in for a 1-unit change in. For our hands-on example, we'll use a simple data set, house prices. This data set includes the size of the house and its corresponding price. We'll predict house prices based on their size. You can download this data set from the link in the description or use any similar data set you have. Let's get started with the implementation. We'll follow these steps. First, load the data. Second, visualize the data. Third, implement linear regression from scratch. Fourth, make predictions. And finally, evaluate the model. Here's the Python code for each step. Python number import necessary libraries. Import numpy as np import pandas, as pd import matplotlib pyplot, as plt from sclearn.metrics, import mean squared error data, equals pd, read csv, houseprices.csv. Replace with your dataset path. X equals data, size. Values, y equals data price. Values, x, plt.scatter, x, y, color, blue, label, data points. Plt x label, size. Plt I label, price. Plt.title, house prices versus size. Plt.legend, plt.show, cost E1, 2, P, sum, npt square predictions y. Return cost def gradient descent, xy theta, learning rate, iterations. M equals len y, cost history equals np zeros iterations. For I in range iterations. Predictions equal x dot theta. Theta equal theta. 1m xt dot predictions y. Cost history e equals compute cost theta x y. Return theta cost history. Initialize parameters theta. np zeros x b shape. Learning rate 0.01 iterations. 1000. Run gradient descent theta. Cost history. Gradient descent. B. Y. Theta. Learning rate. Iterations. X. np ones. X. Shape. 0. 1. X. Return x as b. D. Theta. Predict prices. X new. np array. 1500. 2500. Example sizes predictions. Predict new theta. Print predicted prices. Predictions. Plt dot scatter x y color blue label data points. Plot x y pred color red label regression line. Plt dot x label size. Plt label price. Plt dot title house prices versus size. Plt legend teach. Plt dot show. Let's break down the code. First, load the data. We load the house prices dataset and prepare our feature, MAU, and target. We also add a column of ones too to account for the intercept term. Second, visualize the data. Plot the data points to understand the relationship between house size and price. Third, implement linear regression. We define two functions, to calculate the cost function and to update the parameters using gradient descent. Fourth, make predictions. Using the trained model, we predict house prices for new sizes. And finally, evaluate the model. We calculate the mean squared error, MSE, to measure the model's accuracy and plot the regression line. And that's a wrap. We've built a simple linear regression model from scratch, implemented gradient descent, and made predictions. This hands-on approach helps you understand the inner workings of linear regression and how to apply it to real-world data. If you enjoyed this tutorial, make sure to like, share, and subscribe for more data science content and machine learning tutorials. If you have any questions or suggestions, leave a comment below. Thanks for watching, and see you in the next video.